Hello and welcome to Following Swift Evolution. In this episode we are gonna talk about the proposal SE0195 introduce user-defined dynamic member lookup types. And this is one of the most exciting proposals and additions to Swift 4.2. To talk about this in depth, I need to go back into the beginnings of it. I'm not even sure if this is the first time this show up on the Swift Evolution forums or the mailing list, but this was the post where Chris Latner talked about introducing this new dynamic behavior into Swift. In case you don't know, Chris Latner is the creator, the original mind behind Swift and LLVM and other super interesting projects that we need to be thankful for. But the most interesting thing is that Chris left Apple a while ago and now is working with Google in the TensorFlow team, improving all the new machine learning stuff that Google is doing. And one of the super cool stuff is that he's trying to help Swift become a better language to be used in that environment, in the machine learning environment. One of the things that we need to be realistic about is that in that environment and in many others, Python and other dynamic languages are used a lot, and Swift doesn't have a way to get into that market unless it does some changes. One of the things that they wanted to do was to be able to increase the interoperability between Swift and Python. As you can see in this formal document on the TensorFlow Swift project, it's all about increasing the interoperability with Python. And also, if it's done properly with any other language, the approach they are taking is to build into the language the capabilities for Swift to be able to handle at compile time unknown members. So in case of a dynamic language, you don't know and you can't know at compile time all the members that an object can support. And with this new addition, Swift is able to work with that and fall back to a user level code that will find the right method to call. This is similar to what we already have in Objective-C with the forwarding and NS invocation and proxies and all that fancy stuff that Objective-C does at runtime. This adds similar capabilities to Swift. This proposal has had many different versions and reviews and different forum posts talking about it, discussing if this is the right approach for Swift, if we even should think about it. In the beginning, like a lot of people was opposed to it because basically you are trading the static type checking that we are used to in Swift, and there is a lot of fear of a lot of libraries are starting to use this for doing dynamic stuff, and then we start losing all the static typing and compile help that the compiler gives us, and that's what we love Swift about. But one of the most important things here was, even when the goal, it was an important goal, improving the interoperability of Swift with other languages, especially dynamic languages, the underlying idea was that we don't want to include all the specific logic to interoperate with Python now, but with any dynamic language in the future into the Swift compiler. That's already done for Objective-C and C, and it's using Clang for that, but all the overhead that the compiler and the compiler writers need to deal with just to support that, it's something that we don't want to repeat on the community. We don't want the compiler people to be worried about all these dynamic languages when they are developing a new feature, for example. Approach that it was taken, it was to introduce this new dynamic callable annotation that tells the compiler that if it cannot find a member that belongs to this type, it falls back into doing a runtime call with a specific method that the type must support. And in there, then the type can return any object that it wants. This is basically everything that is needed to look up at runtime dynamically members of a type that are not known at compile time. But the other important part, and that's part of a second proposal that is still in progress of implementation and discussion, it's that once you have that dynamic type, you also want to be able to do a call with arguments to that type. And that's a separate proposal that we are not going to discuss here. To take a look at what can be done with this new annotation, let's jump into Xcode and just basically do a simple struct that adopts this dynamic member lookup. Once you do this, basically the compiler now it's telling you, please implement this subscript with the dynamic member. To do that, we just need to implement this subscript, or is a subscript with a dynamic member with the name This name is basically the string representing what the user wrote, what the user is trying to access to this type. And the interesting thing is that we can return anything we want. In this case, for example, let's just return an optional string, or even in this case, let's go crazy and just return a string. And this is important that we can use optionals there, and I'm going to talk about that in a bit. With this done, we now can create an instance of this, and basically here, there is no completion because this type that we created, it doesn't have any members on it. But what it's now completely new is that you can write here anything that you want, and Swift is going to execute this without any complaints. And as you can see, the return of this is actually the name that we used to call it. What happened here is that Swift took a look at compile time. This anything, I don't know what it is because it's not defined on the struct, and I cannot find it anywhere. There is no extensions, there is no protocol, there is anything that conforms to this. But I know that this type adopts the dynamic member lookup. So what I'm gonna say is I'm gonna accept at compile time this call, and it's fine, I'm not gonna complain about it. And then at runtime, what I'm gonna do is call this subscript with this thing as a name. And in this case, we are just returning this name as that. We could, for example, do something different where we return the number of characters that the member lookup had, and in this case, we just return an integer. If we now run this, the return type of this completely changed, and now it's an 8. If we can put here whatever we want, that the compiler won't complain, and I'm laughing because we are not used to this in Swift and it's kind of crazy. And it just works, it just returns the count of that. This opens a wall of possibilities, and it's a wall that we need to be careful with. There was a lot of argument saying that Swift already has these kind of things, like with implicit unwrap optional, with force unwrapping stuff. Even if you start using any object and you are interacting with Objective-C, at that point you are just hooking to the Objective-C methodology and anything goes. But as a community, we have proved that we don't abuse of these things, that we have been writing mixed code bases for some years now, and we have been interoperating with Objective-C, and we do it when it's necessary, but we don't abuse it, and we write our own libraries with type-safe code in Swift using all the power of Swift when it's needed. So what other things are interesting to talk about with this dynamic member lookup? The interesting thing is that you can still write functions, and the compiler knows that that exists, so you are perfectly safe on actually calling this, and this at compile time it knows what function it is, what things it returns, if it throws, it knows everything. This is now like normal Swift that we're writing. It's just that you can also call anything else, and the compiler won't complain. Another important aspect of the dynamic member lookup is the return type. A lot of the conversation was also around how to deal with cases where this doesn't exist. Obviously, if you are used to any dynamic language, any language deals with it in a different way. Some languages throw an exception at runtime. If you remember from Objective-C, when you call a method that an object doesn't understand, it throws no select or recognize exception. In Ruby, there is something similar. In JavaScript, there is the undefined. And so for this reason, every language has a different way of dealing with it. It was really important that the proposal didn't just crash at runtime. So a smart way of solving this was just adopting the things that Swift is good at in describing what kind of errors can happen. In this case, because I know that I'm gonna receive a string, because basically that's the only way of executing this code, I can just count, get the number of them, and just return it. There is no possibility of failure. So even if this is less, let's say, type safe in some sense, I perfectly know that this is the behavior that I want, that whatever the user writes here, it's fine. It's just gonna return a count number of characters that are here. But if we're doing something else, for example, let's say we want to return an int, assuming that that we could create an integer from an int. Now the compiler is telling us, well, the constructor of an integer, it returns an optional, because of course, like if you put this is not an integer, I cannot do anything with it. But the interesting thing is that we can say, okay, this dynamic member, it returns an optional integer. And now we are opting it into the default behavior of signaling failure on Swift, which is the most basic thing, is just optionals. And everything else just works as intended. Like, we know that this is going to be an optional integer, we know that here it says nil, and if we change and actually call a number on it, it will give us the number as an integer. It just works as we intended to work. If you imagine that here we have to deal with some unexpected behavior and we wanted to actually return a more formal type, we actually could, in theory, make this function throwing and remove the integer type here and probably just return some error here. The problem that we have here is that this is unrelated to this proposal, but it's actually a limitation of current Swift that hopefully it's fixed in the near future, that subscripts cannot throw yet. In this case, we don't have any other way than just returning an optional or returning an object or an enum, for example, that it's a result type, something like that. But we cannot hook into the throwing system for dealing with errors at this time. Hopefully in the future this is fixed, and the nice thing is that the proposal automatically will just work with it because the proposal is not doing anything about return types or specific error codes. So that's a way of bringing back the safety of Swift, the nice things about optionals, and in the future with throwing, to this dynamic world that this proposal is introducing. So in my opinion, it's a really well thought way of dealing with it. Another way of seeing this addition is that it's just syntax sugar on the compiler. In the same way that we have syntax sugar for optionals, or we have the try, catch, everything is syntax sugar about some underlying functionality. We can think about this, of just syntax sugar, to basically a call on this subscript. And here we can just pass any string that we want, and it basically just works. So writing this is just syntax sugar for this. And that's another thing that the Chris Latiner talked about in the beginning of the suggestion for inclusion on Swift, the fact that he already had a working Python prototype. It's just that it was cumbersome to write because you had to be doing things like this, or for example, using these characters instead of parentheses. It was weird. In the same way that on the next proposal that adds calling into any type, it also you can make it work in other ways, but it's just cumbersome and doesn't feel like Swift syntax at all. So this proposal, you can see it just as syntax sugar to make things like this easier to read. Now that we have seen how the proposal works and how you can easily implement a type that has this functionality, I want to show you some examples that I've seen in the community or the Python interoperability that the TensorFlow team has been working on, just so you get an idea of how this can work. To check the Python interoperability, I recommend you to take a look at the Swift project on GitHub if you change to the TensorFlow branch. So if you check this Python Swift file, this uses the Python runtime and to offer Python objects and Python value types to Swift. And as you can see, they implement dynamic member lookup, that is the one we're talking about, but also the dynamic callable, which is a proposal that is gonna come probably in Swift 5. And as you can see here, they are not doing anything super crazy. They are just using the Python runtime to check for some objects and wrap them in these Python objects. In that way, offer them to Swift. And thanks to these new proposals, calling this code, it's as nicer as calling any other Swift code. It's really nice. I think that people that uses these machine learning libraries, it's gonna be really helpful with this. But let's not stop there, and let's look at how we can use this for other things that are not just interoperating with other languages, but actually to write libraries in Swift that benefit from this new behavior. For that, I'm gonna show you some things that I found online. For example, in this case, I want to show you Chris head of this member lookup gist that he wrote, where he uses member lookup to write a wrapper around HTML tags. And as you can see here below, we can just call span, h1, and any other tag that is basically supported by HTML, and we can pass stuff here to add the attributes to it. But if you look at the tags, they don't define all these things. So it's using this dynamic runtime behavior to actually create these HTML tags. Another example of this is from Gregor, part of the compiler team, that used the dynamic member lookup to expose the environment variables. I found this one really interesting because sometimes it's quite a pain, to work with environment variables. You often forget how to deal with them. And yes, we have this set environment and set environment, and even the get environment functions that we can use, but it's nice to have like a wrapper on Swift. And in this case, it's super nice because yes, you could write a type that defines with its own properties, or even if you just want to use constants or an enum, there are many other ways to do this and make sure that you only can call environment variables that you presume that are there. But if you are not in that scenario, it's actually really nice to be able to just create an environment object and just call with any environment variable that you want to retrieve and make it just work. Here you have my username, and as you can see, this user environment variable, it's not defined anywhere. It's just using this dynamic member lookup to look for it. And in this case, because obviously you can write here anything that you want, like, I don't know, machine name, which I don't think that exists at all, but it's fine because we can return an optional, and I need to deal with that in this case by just coalescing it into an unknown user string. Another interesting thing that this example shows is that we can write this in structs, and the subscript can implement a setter, which means that we can actually set environment variables as we wanted. Like the machine name that we were talking about, we can say that it's my Mac. And if we run this, it's actually set that. As you can see, it's actually set. So this shows another possibility of writing setters to actually mutate something dynamic. Another interesting usage of this, as displayed here with a gist from Mark Sands, actually giving accessors to database in a similar way like Active Record does in the Ruby world. For example, you can find here that you can do find by ID or find by name, and these things are actually not implemented on the query or on the user, because what the database actually exposes is this more Swifty way of writing it, which is like with a method that has a label parameter. But in this case, imagine that we could use it like this, and it's actually a different way of writing it. Again, I'm not saying that this is the best way of now writing access to our databases, but it's another possibility that we have now and that we can explore. Finally, there is another example that everybody that thinks about dynamic member lookup is thinking about, and it's JSON decoding. We are used to now have Codable in Swift, and there are many libraries that bring type safety into it, but imagine if we could just access it as we need it, like for example you do in JavaScript. There are probably libraries that are trying to do this now. I haven't used one, and usually with Codable we have more than enough, but it's interesting to see that now Swift is capable of doing all this dynamic stuff. That's all the examples that I had for you. If you check the proposal, they also talk about future directions with Python code completion, and there are ways of doing that. There are ways of helping the IDEs do that. And even if dynamic languages, by definition, they are not capable of offering all these code completion niceties, because obviously they are dynamic and you cannot know everything at compile time. But in reality, people just use dynamic languages like if they were compiled, because basically they pre-process it and they make sure that everything is fine. They have linters. Nowadays they even have compilers. So it's actually really possible to bring all these nice things into this interoperability story. Was there an alternative of doing this? Was there an alternative of bringing, for this specific case, Python support, actually add direct language support to the compiler, but that opens Pandora's box? And then what if we want support for Ruby? What if we want support for Lua? What if we want support for any other language? That's not scalable at all. And it makes sense that Swift has direct support for things like C, because it's like the lingua franca of programming languages. Even it has a lot of sense that it has Objective-C, because otherwise nobody will have been writing Swift in the freeze-tree for years. But it doesn't make sense to keep repeating the same story over and over and making the compiler implementation more complicated. So for me, this is the right call, and this opens the door for a lot of things that probably nowadays we are not even thinking about. Another important thing that was suggested, and I had conversations on the forum around this, was the introduce of something similar to type providers from F# or TypeScript, and it's the fact that you could provide a configuration file or a provider file into the compiler, and when the compiler is actually doing the freeze part of the compilation phase, it will assume that these dynamic types have all these properties and methods that you have defined in these type providers config files. This is actually super nice because in dynamic languages is what they are using to bring all this code completion and all these refactoring tools, and it will be super interesting to be able to introduce this into Swift to have, for example, you can generate a JSON schema from this, and you could do a lot of stuff that we are now, thankfully, like we have other solutions for it, but it's another way of approaching similar problems that it will open another door of possibilities. In my opinion, this will be a great solution if we had a nice metaprogramming already in Swift, which I think it's the part that is lacking most in Swift nowadays. And I think that in the future, if we improve the metaprogramming capabilities of the language, adding something like this will become just a user-level code that can deal with this, which will be super, super interesting. I think that's it for this video and for this proposal. It probably was a little bit longer than I anticipated, but I think it's a super interesting proposal that not a lot of people has been talking about, because obviously it doesn't affect us a lot in our days to days. It was super important to get it in to try to bring more people from other languages into our community. For the rest of us that write applications for iOS and Mac, and probably if you are also just doing some server-side stuff, you actually don't really need these capabilities. So I think that my mission was to give you an overview of everything introduced by this dynamic member lookup proposal, and remember that callable part of it is also coming in the next version of Swift, and show you all the doors that this open, tell you to keep an open mind, but also be careful on the ways we use this. Ultimately, we want Swift to be a great language, and things like this, I think they are important for it. So that's it for this video. Remember, if you learned something and you like this video, press the like button, subscribe to get notified with the new videos of following Swift evolution, and see you next time.